And number 12 says, using the Z table, find the critical value or values for an alpha level of 0.09 two-tailed test. So what we're going to do is we're going to draw our bell-shaped curve. And because it's a two-tailed test, you're going to indicate that on the bell-shaped curve. So a tail on the left and a tail on the right. And you want to find the z-scores for each of those values. The z-score on the left will be negative. The z-score on the right will be positive. The sum of the areas must add up to 0.09. But because there's two parts, I'm going to take my 0.09 and divide that by 2. When I take 0.09 and divide that by 2, I get 0.0450. And that means each shaded region is going to be that probability of 0.0450. Remember, the bell-shaped curve is symmetrical, the symmetrical distribution. So if I find the z-score for the left side of the distribution, I'm also finding the z-score for the right side of my distribution, except I'm just changing the sign from negative to positive. So we have a probability. We're going to go into the body of our z-score table, and we're going to find the closest value to negative, it's going to be positive 0.0450. So let's scroll down. And if we look here, the value that we're looking for is between two values. It's going to be between 0.0455 and 0.0446, because 0.0450 is between those two values. You're going to pick the value that is closer to the probability, that is 0.0450. In this case, 0.0446 is closer than the probability of having 0.0455. Therefore, if you take that z-score, it's going to be negative 1.70. So here, z is equal to negative 1.70. Because it's a normal distribution and it's symmetrical, the z-score on the right side will be positive 1.70. And those are the critical values in this case. On the answer sheet, it gives you 1.69, but we're pretty sure that a different z-score table was used for that one that's more accurate. But in this case, and especially for your final Connect Math, you're gonna do it the way I just